Now, remember, are all linear equations rational equations? Yes. Right, very good. Are all rational equations linear? No, because there are rational equations in which you have variables in the denominator. Okay. All right. Now, we can classify equations depending on their solutions in three different ways. Okay? So, we can classify equations three ways. All right, so let's look at this example. So if I ask you to solve this equation, let's say we had 2x minus 5x plus 2 equal 6 minus 2 times x plus 1. All right, so I want to solve this equation. So I think one of your worksheets says solve the equation, also determine whether it's conditional, identity, or inconsistent. Was that one of them? Okay, so that's what we're working on right now. All right, so you're going to solve the equation, and then you're going to answer the question. Is this a conditional equation, an identity, or is this an inconsistent equation? All right, so you got to solve it first. You got to solve the equation to determine that. So now this you could have done already, the actual solving here. So what's the first thing you're going to do? Distribute. Okay. Now on the left side, what are you going to distribute? Negative 1. Good. So this becomes 2x. Come on. Minus 5x. Guys, negative 1 times 5x, negative 5x, right? Minus 2. Equal. Now over here, you're going to say 6 minus 2 is 4? No, you're going to distribute what first? Negative 2. So that's 6 minus 2x minus 2. Okay, once you do that, what is the next step? Combine like terms. So on the left side, what can I combine? All right, so it's 2x minus 5x. Minus 2 equal, and over here I can combine and those are called your constants, right? So it's 6 minus 2. So that's 4 minus 2x, or minus 2x plus 4. Does not matter. All right. Now when you get to that point, notice this is a linear equation. When you get to that point, remember the idea is to solve a linear equation is to bring the variables one side, constants to the other. It does not matter which one you do first. So tell me which one you want to do. Okay? All right. So a negative 3x and a positive 2x is? Nope. Negative x. Minus 2 equal 4. What's the next step? Add 2 to both sides. Combine like terms. Negative x equal 6. Now remember, you're solving for x. You haven't gotten x yet. Yeah, so remember, negative x means the same thing as negative 1x, right? So I don't want a negative 1, though. I want the coefficient of x to be what? Positive 1. So you can divide both sides by negative 1. Remember, what you do one side, you do the other. So negative 1 divided by negative 1 is now a what? Positive 1. 1 times x is x. So what does x equal? Negative 6. Okay? All right. So this equation is true. This equation is true only if x is what number? Negative 6. This is a true equation under the condition that x is what? Negative 6. So note that the original equation is true under the condition that x equals what? -6. Any other numbers, you're going to make it a false statement. It's true only when x is what? -6. Now notice in the statement I just wrote is the word condition. So this equation has at least one solution. What's the solution? -6. So it's called a conditional equation. So this is a conditional equation. All right, so it's a conditional equation. So if you get x to be a real number, it's a conditional equation, because that equation is true only if x are those numbers. Okay? All right? All right, so that's number one. Okay, let's look at this one. So almost all the problems you've done, not all of them, but almost all the problems you've done in the last 2 days with equations were what kind of equations? Conditional equations. Yes? Yes. Yeah. Number 2. 2 times x plus 5 minus 3 equal 2x minus 5. So 2 times x plus 5 minus 3 equals 2x minus 5. So if I solve that equation, what's the first thing you're going to do? Distribute the 2. So I get 2x plus 10 minus 3 equal 2x minus 5. What's the next step? Combine like terms. I get 2x plus 7 equals 2x minus 5. So that's where I'm at. Okay. Now remember, just like you did before, you brought all the variables to one side, constants to the other. Tell me what you want to do. Let's bring the variables to one side. So what are you going to do? Subtract 2x. Now notice what happens when I subtract 2x. So when I subtract 2x, I get 7 equals a -5. So your variables go away, right? There aren't any variables left. So now look at that statement. Is that a true or false statement? That's a false statement. That's a false statement. So what that means is that original equation will never have a solution. There are no solutions. And it kind of makes sense because if you look at this part right here, you see these the left and the right side. There are how many terms on each side? 2. The first terms are identical, right? They're exactly the same. So if I cover them up, then that says 7 equals what? So no matter what I plug into x, notice this, no matter what I plug into x, let's say 5. What's 2 times 5? What's 2 times 5? Is 10 plus 7 the same as 10 minus 5? No. No matter what you plug in, nothing's going to work. So when the variable disappears, you've got to look at your statement. And you ask yourself, is it true or false? It's false, so that means there is no solution. So you're going to say, you remember there's going to be a blank solution. It'll say something like this, solution x equal blank. You're going to say what?
No solution.
No solution. Or you can use what symbol? The empty set symbol. Now, if there is no solution, it's called an inconsistent equation. So this is an inconsistent equation. That's what goes on the top of the equation. Okay? So that's an inconsistent equation. All right, so an inconsistent equation has what? No solution. Don't say false solutions, just say no solution. Okay? So we did a couple of problems. Remember when we solved the rational equations and one of my proposed solutions was a restriction? And in blank you said the solution was what? No solution. Then that equation was what kind of equation? Inconsistent. All right. Number 3. Suppose I had this. 4x minus 7 equals 4 times x minus 1 minus 3. 4x minus 7 equals 4 times x minus 1 minus 3. So how are you going to solve that equation? Distribute the 4. And so I get 4x minus 7 equals 4x minus 4 minus 3. Combine like terms, you get 4x minus 7 equals 4x minus 7. Now, you can stop at this point if you want to. You don't have to bring the variables to one side. Because what do you notice about both sides? Now listen to the words. They are identical. Right? They're identical. 4x minus 7 is on the left, 4x minus 7 is on the right. So that means that no matter what I plug into x, the left side is always going to equal the what? Right side. So how many solutions are there? An infinite number. Any real number works. 1.7 works. 4 times 1.7, 4 times 1.7. And this side you're subtracting 7, and this side you're subtracting 7. Are those going to be the same number? Yes. If you plug in 6 for x, 4 times 6, 4 times 6. You're subtracting 7, subtracting 7. Are those going to be the same number? Yes. Now, if you do want to bring the variables to one side, notice what happens. Minus 4x, and what are you left with? Negative 7 equals a negative 7. So notice right here, when the variable disappeared, we asked ourselves, is this a false or true statement? Right here. That was a false statement. So we said what? No solution. Here, this is a what? True statement. True statement. So the solution, this is how you're going to write the solution now. The solution. All right, now, on my math lab, here's how you're going to write it. Solution, you're going to say this. You're going to say the set of x's such that x is a real number. That's how you're going to write that. So that means this. On your worksheet and on the test, you just have to say this. All real numbers. Okay, so that means this. So any real number is a solution. But in my math lab, they're gonna write it in set notation in my math lab. So just when you do that section, I haven't assigned it yet. I will tomorrow. When I assign it, you're gonna see this set notation. So all real numbers means a set of x's such that x is what? A real number. So that's how you read it. A set of x's such that x is a real number. All right, so remember this reads the set of x's. So the set being those braces, set notation, the braces on the outside, that means set. The set of x's, this little vertical segment here, that means such that. So set of x's such that, and then x is a real number. Okay, now notice though, when I got to this point, I saw this right here and I said that those two sides were what? Identical. So you tell me, do you think this is a conditional equation, an inconsistent, or an identity? Identity. So this is an identity. So if your solution's all real numbers, you're going to say identity. If the solution is all real numbers, x equal all real numbers, then it's an identity. Okay? All right, so those are your classifications. So if you get x to be a number, it's what kind of equation? Conditional. If your equation, the variables go away and it's a false statement, you're going to say no solution, and it's what kind of equation?
Inconsistent.
Inconsistent. If your variables go away and it's a true statement, how many solutions? All real numbers. All right. Okay? All right, now let's look at this example. So let's look at number 4. All right, number 4. I'd have x divided by 2 minus 3 divided by 4 equals 10 minus 15x divided by 6. So x divided by 2 minus 3 divided by 4 equals 10 minus 15x divided by 6.
That's from part 2.
I'm sorry?
That's from 1.2.
It's just solving linear equations. Okay? Okay, the LCD. The LCD is 12. Okay, the smallest number that 2, 4, and 6 go into is 12. Are there any restrictions? You better say what?
No.
No, because there aren't any variables in the denominator. All right, now once you find your LCD, remember on the left side, you're going to enclose that in parentheses because you have 2 rational expressions here. So you're going to say times 12 equal. And over here, since that's just one rational expression, I'm just going to leave it as it is, and I'm going to say times 12. All right, now, what's the next step? Distribute. Distribute. So you're going to say 12. Oops. You're going to say 12 times x over 2 minus 12 times 3/4 equal. And then I'm just going to rewrite this because all I wanted to do was just use the distributive property. That's all I wanted to do. Okay, now we're going to do what? Simplify, reduce. Okay. Remember, the whole point of multiplying by the LCD is to make these denominators 1s. 2 to 2 is 1. 2 to 12 is 6. Kind of makes sense because that's 12 divided by 2. 6. 4 to 4 is 1. 4 to 12 is what? 3. Kind of makes sense because 12 divided by 4 is 3. 6 is 1. 6 into 12 is 2. But what did we say we would, you may want to do at this point for this one here? Put that around parentheses because the whole thing has to be multiplied by what? 2. So here's what I have. I have 6 times x, which is what? 6x. Minus 3 times 3, which is 9, equal. And I'm just going to rewrite this over. Now, how to get rid of these parentheses? Distributive property. So you get 6x minus 9 equal 20 minus 30x. All right, what's the next step? Bring the variables one side, constant the other. So let's add 30x to both sides. So I get 30, 6x minus 9 equal 20. So 36x equal 29.
Divide both sides by 36.
Divide both sides by 36. And so I get x to be
29 over 36.
20 over 36. So I get x to be a number, right? And it's not a restriction because there aren't any. So that is the solution. So is this a inconsistent, identity, or conditional equation?
Identity.
Well, it's not an identity.
Okay, consistent.
No, don't use the word consistent. We need in this book. You're going to use the word conditional. Conditional.
Oh,
An identity is where you get all real numbers.
I know. You know, we are scattered, right?
Okay. All right, dude. All right. Number 5. Seven divided by y squared minus y minus 2 equal 1 divided by y minus 2 minus 2 divided by y plus 1. So 7 divided by y squared minus y minus 2 equal 1 over y minus 2 minus 2 over y plus 1. All right. Is this a linear equation or a rational equation? It's rational. Are you going to have restrictions? Yes, because your denominator has variables in it. Now that's where you're also going to have to find the LCD, and you're going to have to factor. So let's look at the right-hand side for right now. See this y minus 2? Can you factor y minus 2? No. But you do know what the restriction is for that one. What's the restriction for this y? 2. So far I know this. I know that y cannot equal what? 2. I also know this. I also know that this factor, if I want this to be a 1, then I've got to have what up here? A y minus 2 to divide it out. So that has to be part of the what? LCD. We'll put that in parentheses just like this. Now let's go to the next one. Y plus 1. You can look at that and tell me what y cannot be. What makes this y plus 1 0 when y is what? Negative 1. Now you can also tell me what your other factor will be for the LCD. Y plus 1. All right, so that takes care of this side. This side was easy. Let's go to this side. You got to remember some factoring from last semester. Now, for right now, for us, it's not that difficult because you're going to factor this. Usually what's going to happen is that you're going to factor this using these factors. All right, so remember when you factor a trinomial, when you go back to the factoring, when you factor a polynomial or a trinomial, you look for a GCF first. What is the GCF here of those three terms? What is the GCF? Say again? What's the GCF? What? 1. Yeah, 1 goes in all of them, so GCF is 1. So remember, there is no other number other than 1 that they all have in common, right? If all of these, I think yesterday we did one where we had to take out a 3. So the GCF was a 3. You could take out a 3. Here is just a 1, so there's nothing else you can do in terms of the GCF. The point being that whenever you factor, remember the first thing you have to do when factoring is always look for the GCF, the greatest common factor. Since the GCF is 1, then you're going to go and you're going to do the two binomials. All right? Usually, though, for us, these two binomials are going to be these two. I'm hoping you do know how to factor because you spent almost a whole semester on factoring. Okay? Because that idea of factoring is going to be important when we get into the next section. It's not going to be this simple. So here, you know what the factors have to be. What are the factors for this? Y minus 2 times y plus 1. And then you check yourself. What's y times y? Y squared. What's the outer? Y. What's the inner? And what's a negative 2y and a y? A negative y. That's what I wanted. And what's a negative 2 times a positive 1? A negative 2. All right. And now let's go back to the restrictions. What are the restrictions for this factor right here? What makes y minus 2 0? When y is 2, I already have it. What makes this 0? Negative 1, I already have it. Now let's go to the LCD. If I want this right here to be a 1, then it has to be part of your LCD. Do I already have it? Yes. Do I already have this one? Yes. So that's your LCD. So your LCD is only y minus 2 times what? Y plus 1. All right. Once you find your LCD, what was the next thing we had to do? Multiply both sides of the equation by the LCD. All right. So here we're going to have the LCD, y minus 2 times y plus 1 times the left-hand side, which is just one rational expression. Now remember, based on our discussion yesterday, are you going to write the denominator as this trinomial, or are you going to write it as the two factors? The two factors. Because you want to do that because you can see you can easily reduce. They're listed. Okay, equal. The LCD times the right-hand side. Now, the right-hand side has two rational expressions, so put that in parentheses. 1 over y minus 2 minus 2 over y plus 1. Now, based on when you were doing that second in-class worksheet, some of you were trying to do too many things in your head. You were not writing the steps. Those of you that wrote the steps did a whole lot better with getting the answer than those of you that did not. Because those of you that did not, you didn't get your answer right, and they had to tell you to go back and work on it. Those of you, for the most part, that did do the steps got it pretty easily. So it's very important. You try not to do too much in your head. Mathematically, you got to write things out. You're not at that point to where you can visually look at it without having some kind of error. You're not. All right. Now, once I included this, what is the next thing I should be writing, which is what most of you did yesterday? You wrote out. You're going to rewrite this and you're going to do what here? Distribute. So you're going to say y minus 2, y plus 1 times this equal, and then you're going to distribute this. So you're going to say y minus 2 times y plus 1 times the first fraction minus y minus 2, y plus 1 times what? Second fraction. That's what you need to write. It only took 15 seconds. Okay? 15 seconds, all it took. Now, what is the next step? Reduce. The y minus 2's divide out. The y plus 1's divide out. Over here, what divides out? Y minus 2's divide out. Notice I put 1's in their places. Over here, what divides out? Y plus 1. Once you do that, then it's easy to see what you end up with at that point. What's 1 times 7? 7. Equal. What's 1 times y plus 1 times 1? Y plus 1. That's all that is. Now be careful with this one. Minus. Y minus 2 is in parentheses, right? Times 1 times what? 2. So you need to write this as minus 2 times what? Y minus 2. Just like that. Now you might say, well, why didn't you put the first one in parentheses? You could have. You could have. But if I do, that's just what in front of the parentheses? 1. And 1 times y plus 1 is still what? Y plus 1. So that's why I didn't. But here you really need to. Because if you didn't, you'd probably mess up around that second term. What's the next step? Distribute. So I get 7 equals y plus 1 minus what? 2i plus 4. What's the next step? So I get 7 equals, all right, so let's see, negative 1y or negative y plus 5, okay? Subtract 5 equal negative y, divide by negative 1, so I get y equals negative 2. Is that a restriction? No. That's not one of my restrictions, right? So if it was, though, if negative 2 was listed here, then you would say what? No solution, and it would be what kind of equation? Inconsistent. All right. Since this proposed solution, so remember, yes, we use the word extraneous. So is negative 2 an extraneous root? No. If this was a positive 2, would that be an extraneous root? Yes. Okay, very good. Remember, that would be a false solution. It satisfies this linear one, but it doesn't satisfy the original. All right. But it's not a restriction, so it is a solution. So is it an inconsistent equation, an identity, or a conditional equation? Conditional. So this is a conditional equation. All right. Okay. All right. Now, okay, so let me give you